Okay, guys, so this is the 4.7 notes. So this is the thing we did with inequalities with absolute values. Okay. Um, so the learning objective is I can solve inequalities with absolute values. That would require us to know what the heck an absolute value is. Okay. So the first thing we're going to talk about, okay, the first thing we're going to talk about is what is an absolute value. An absolute value describes the distance from zero that a number is on the number line without considering direction. The absolute value of a number is never, ever, ever negative. We talked about this in class a lot at the beginning of the year. We talked about like, okay, would you ever say I'm negative 5 miles away from Hillcrest? That doesn't make any sense. You would just say I'm 5 miles away. Okay, so that's what absolute value is, and that's what we're talking about. Okay, so what we're saying is if you look at this number line, let's look at a number line. I want you to mark on this number line the places that would be, let's say 3 away from 0. Where are you -3? Or sorry, I just gave you the answer on accident. Oops. Where are you 3 spaces away from 0? Okay. So most people would mark this one really quick off the bat. At 3, you're 3 spaces away from 0. You also should have marked -3 because you're also 3 spaces away from 0 there. So like this would be saying like the absolute value of x equals 3. These are your answers, both -3 and 3. Okay. It could be either. You could be to the right 3 or to the left 3. So the way that absolute value looks are these bars. Okay. These just straight up and down bars over here. That's what absolute value looks like in an equation. So if you're looking at this inequality right here, you would read that as the absolute value of 3x minus 12 is greater than or equal to 6. And what you're saying is that 3x minus 12, whatever it is, its distance from 0 is bigger or equal to 6. So it's further away from 0 than 6. Whatever it equals, it's further away than 6. So the way that we solve these is this. Here we go. Step 1, if necessary. Isolate the absolute value on one side of the equal sign or inequality. So what that's saying is if you have these bars here, you need to make sure the bars are by themselves on one side of the equal sign or inequality. That's what isolate means, get by itself. In this case, that's already done. Okay, you don't have to worry about that because they are isolated. There's not like a times something out here. There's not like a minus something over here. It's just the absolute value greater than or equal to, and then 6. Okay, so step 2 is to rewrite as two separate inequalities. Okay, so what you do is you take this middle piece, you take this 3x minus 12 and you copy it down, 3x minus 12. And then over here, you leave the greater than or equal to 6 just like you saw it. So really, this one is just copying this down without the absolute value signs. So this would be true. If we're looking at our number line, here's 0, here's 6. We're saying, hey, whatever 3x minus 2 is, it's somewhere over here because the distance from 0 is bigger than 6. But if we were over here, wouldn't the distance from 0 also be bigger than 6? So what we have to do to deal with that is we copy down this middle part, the 3x minus 12, and then we have our -6, and we flip this sign the other direction. We flip the inequality around. If it helps you to think about it this way, you can say, oh, well, you multiplied by a negative, so you got to flip it around. Okay? If that helps you think about it, you can think about it that way. But we need both because it could be to the right, like this one is saying, but it could also be to the left, and we need to include that. Okay? So once you've done that, once you've separated the inequalities out, you're just going to solve each inequality. So if we have 3x minus 12 is greater than or equal to 6, we would solve that by adding 12 to both sides. And we would get 3x is greater than or equal to 18. And then we would divide by our 3, and we would get that x is greater than or equal to 6. Okay, that one's done. Not too bad. But we would also do 3x minus 12 is less than or equal to negative 6. We're still going to add 12. So we would get 3x is less than or equal to negative 6 plus 12 is a positive 6 now. Divided by 3. And x is going to be less than or equal to 2. So we have two separate inequalities. We have x is greater than or equal to 6, and we have x is less than or equal to 2, which it can't do both, right? It can't be bigger than 6 and smaller than 2. So what we do here is we graph both of these, okay? So you'll notice there are no numbers on these. That's on purpose. I want you to label them. For this one, I'm going to start with my 0 over on the left side to make sure that I can get all the way up to 6, okay? So we would take the 6, and we're going to put our dot there, okay? Let me change this color for you guys so it's a little easier to see. So we're going to put our dot on 6, okay? So if we put our dot on 6, then we have to decide, should we fill it in or not? This is x is greater than or equal to 6, so yeah, we're going to fill that in. And we want the ones that are bigger, so we go this direction on our fill-in, okay? So that's the first one. We also need to graph x is less than or equal to 2, okay? So for this one, we would go to our 2 and put our dot. We would fill it in because it is or equal to. And this time we want the numbers that are smaller, so we would go this direction. So this looks a little bit weird, right? This looks odd. Why are there two separate ways that this is going? Okay, so what happens is what we're saying with this, what this graph means is we're saying that if you plug anything 2 or smaller in, this original inequality will be true. If you plug 6 or bigger anything in for x, this inequality will be true. But if you plug 4 in, let's see what happens. So we would do the absolute value of 3, and instead of x, we're going to use a 4, because that's the one we're testing, minus 12 is greater than or equal to 6. So let's test it. Absolute value works a lot like parentheses. We work on the inside first. So 3 times 4 is 12. Greater than or equal to 6. And 12 minus 12 is 0. And what's the distance from 0 for 0? So that's what this is asking right here, is how far away from 0 is 0? Well, 0. Is 0 bigger than or equal to 6? No. So if you plug 4 in, this is not going to be true. It's not going to work, okay? So that's what we're saying here, is if you plug any of these in, you're going to be golden. If you plug any of these in, you're going to be golden. But if you plug anything in here in, it's not going to work. It's not going to be true. So let's do another example, okay? So step 1 was to isolate the absolute value, okay? So here's our absolute value, and this time we have this plus 6 hanging out here, okay? We have to get rid of that before we can do the other stuff. So the first thing we're going to do is subtract 6 from both sides, because we want these absolute value symbols to be by themselves, okay? And 10 minus 6 is, of course, 4. So that's always step 1, isolate, get it by itself. Now step 2 is to take whatever's on the inside and rewrite it into the two inequalities. So we would do 2x minus 6 is less than or equal to 4. So all we're doing is getting rid of the absolute value. Everything else is the same. The other equation we have to write should look like 2x minus 6, so that part's the same, but then we're going to flip this guy around to greater than or equal to a negative 4. Okay, we have to flip that around. And again, the reason we have to do that is because if the distance is less than or equal to 4, it could be to the right 4, but it could also be to the left 4. Okay. Then we come in and we solve both equations. That's step 3. And you'll notice that you're actually going to do the same thing to both equations. You're going to add 6 on both sides for both. So I'm going to go ahead and do it at the same time. You don't have to. You can do them separate. I just know that I'm doing the same thing. So in my brain, I'm like, oh, okay, I'll just keep adding 6 over and over. So -4 plus 6 would be 2. And then we divide by 2. And again, it's going to be the same on both equations. So you can do it at the same time if you want. So x is less than or equal to 5. And x is greater than or equal to 1. So again, we're going to come in and we're going to do the graph. Again, I'm going to put 0 over there, but you can decide where it fits best. First thing is we're going to put a dot on 5. We're going to fill it in because it's or equal to. And this says x is less than or equal to 5, so we're going to want to go this direction. Okay. If you're using pen, I highly recommend you pause before you do anything else. So x is greater than or equal to 1, so we would put this here. We would fill it in because it's or equal to. This time we want the numbers bigger, so we're going to go this direction. So this doesn't look like our first one, right? So what is this saying? What is this graph telling us? So to know for sure, I want to test out some values to know what the heck's going on. So I'm going to test a value over here where it's just blue. I'm going to test a value in here where it's both. And I'm going to test a value over here where it's just green. So let's start with 0. For the record, this is a lot easier in a calculator. So if you wanted to use a calculator to do some of these absolute values, it would help you. Okay. So let's plug in 0. So we would do the absolute value of 2 times 0 minus 6 plus 6 is less than or equal to 10. You'll notice I went back to this original. I did not use this one. I went back to the original. Okay, so then we're going to have the absolute value. 2 times 0 is 0. 0 minus 6 is minus 6. So the absolute value of -6 plus 6 is less than or equal to 10. So the absolute value of -6 is asking, how far away from 0 is -6? The answer is 6. 6 plus 6 is 12. And 12 is not less than or equal to 10. It's bigger than 10. So what we're saying is these values over here didn't work. So we're actually going to come in and we're going to erase this fill in, because where we fill in is where we're saying it works. It doesn't work over here. So we're going to erase that. Okay, now we're going to go back in and we're going to test another one. Let's test this time a 3. So 2 times 3 is 6. So we have the absolute value of 6 minus 6 plus 6 less than or equal to 10. So 6 minus 6 is 0. These keep looking like C's. Those are supposed to be less than or equal to's. Less than or equal to. Okay, so the distance from 0 is 0. 0 plus 6 is 6, and 6 is smaller than or equal to 10. So this one right here worked. Yay. 0 was a frowny face. It did not work. Okay, it wasn't true. So let's try 7. Okay. Okay. So 2 times 7 is 14. So we have 14 minus 6 plus 6 is less than or equal to 10. 14 minus 6 is 8. So the absolute value of 8 plus 6 is less than or equal to 10. The absolute value of 8 is asking how far away from 0 is 8. That's 8. So 8 plus 6 is less than or equal to 10. 8 plus 6 is 14. 14 is not less than or equal to 10. It's bigger. So this one also doesn't work. So we also are going to take this and erase and say, hey, these ones over here actually don't work. So what this is saying when they're going towards each other is that it has to be between the two. So x has to be between 1 and 5. You could also write this like this. 1 is less than or equal to x, which is less than or equal to 5. Okay, so what you're saying is this x has to be in between 1 and 5, okay, for it to work. Up here, it was a little bit different, okay, because they were going different directions. You're saying it could be over here or over here. When they're going towards each other, it has to be where it's both happening, okay? All right, let's do another example. So example 2. So step 1, again, is to isolate your absolute values. So here's your absolute value. This time we've got this guy and this guy hanging out that we need to move away. Okay, so first thing we're going to do is subtract our 4 over. And we get 1/2 times the absolute value of x plus 7 is less than or equal to 5 minus 4 is 1. Now, again, absolute values work kind of like parentheses. So 1/2 being on the side right there means multiply. So multiplying by 1/2 is the same thing as dividing by 2. The opposite of dividing by 2 would be timesing by 2. So if you times by a number and divide by it, these are going to cancel. You're left with a 1. 1 times stuff doesn't do anything. So really, you're just left with absolute value of x plus 7 is less than or equal to 2. Okay, so now your absolute value is finally by itself. Now you can do all that other extra stuff. Okay, so we would rewrite it as x plus 7 is less than or equal to 2. We also need to write that second equation of x plus 7, and this time we're going to flip the sign around. It should be greater than or equal to negative 2. And then we just solve our inequalities. We would minus 7, so x is less than or equal to negative 5. We would also minus 7 on these ones, because that's the opposite of adding. So x is greater than or equal to negative 9. Okay. So for our number line this time, I'm actually going to put negative 10 over here because I need to be able to get to negative 9. Okay. So then we would put our values on. So x is less than or equal to negative 5. So that means it's going to be here, and it's or equal to, so I am going to fill it in. Less than means smaller than, so we're going to go towards the smaller than numbers. And then for x is greater than or equal to negative 9, we would put our dot on negative 9, fill it in. It wants the bigger numbers, so that would be going this direction. Okay, so this one looks a lot like our second one. So remember, what we do is we say, okay, it needs to be, if they're going towards each other, it needs to be where they both are. So this is saying that x would need to be between negative 9 and negative 5 in order for this original inequality to be true. Okay. All right, so I'm going to do number 4, and then I'm actually going to let you do number 3 on your own. But I want to do number 4 with you first. And I do need to erase this to have room to work over here. Okay. So, again, the first thing we need to do is get our absolute value isolated. We also have another grouping symbol here, though, in our division. So we actually have to deal with our minus 5 very first before we can deal with that. So here we would end up with the absolute value of x minus 2 divided by 3 is greater than or equal to 1. Now we can deal with this grouping symbol and times by 3. So the absolute value that we get is x minus 2 is greater than or equal to 3. Okay. So it's a little bit complicated, but you just have to get it by itself. And then we can write it into, so that's isolating. Now we can separate it into 2 separate equations. So we would do x minus 2 is greater than or equal to 3, just like we see it, but without the absolute values. And then we also would need to do x minus 2 is less than or equal to a negative 3. Okay, we have to do both. We would add 2 to get rid of the minus 2. So x is greater than or equal to 5. And then we end up with x is less than or equal to negative 1. Okay. Again, it doesn't really matter what you label your number line as long as you can get to both numbers that you need. So let's start with x is greater than or equal to 5. So we'll start here. It is or equal to, so we'll fill it in. And we want the numbers bigger. We also have x is less than or equal to -1. So we'd go here, fill it in because it's or equal to, and this time we want the number smaller, so it goes this direction. So this is like the first one. And on the first one, we didn't have to do anything special now. What this is saying is if you pick one over here, it'll work. If you pick one over here, it'll work. These ones don't. Okay? If you want to test that, feel free. That will come out true if you plug it into this original inequality. Okay? So I want you guys to do number 3 on your own. Okay? All 4 steps, get all the way done. The answer is on Canvas if you need help. But otherwise, I want you to do that one on your own. I think you're ready to do that. And make sure you fill in the today I learned part. So it's today I learned that to solve an inequality with an absolute value, I need to isolate, step 1, separate, which is step 2, solve, which is step 3, and graph, which is step 4. And that means that. Tell me what these mean. Okay, isolate, separate, solve, and graph is going to mean nothing to anybody but me. So tell me what it means. If you had to explain it to somebody who wasn't in our class, how would you explain to them what you're supposed to do? Okay. If you have any questions, let me know.